For this next video, we are to solve for the integral of the given function f of z equal to z along the parabolic curve y is equal to x squared from 0 to 1. Don't be confused with, of course, we know that a given function is z, and you have your parabolic curve y is equal to x squared, and you have the points 0 to 1, because all of this are actually important in understanding the given function and its integral. We know that the integral, is identified as the integral of f of z dz along the said path, in this case parabolic curve, is equivalent to the integral of f of z of t times the first derivative of your z dt from a to b. Of course, our path here is a parabolic curve, so we're going to use the different form of parameterization intended for the curve. Okay, so we will also be needing that process to identify this one here and probably the a and b values. Now, our parameterization for a parabolic curve, already identified in one of the videos, is actually expressed as t plus I kt squared. If you're not yet convinced with this, of course, you can always review that video. It's on this playlist as well, where our t is between a and b. From this perspective, you can automatically solve for our a and b, because we know that the path is along the curve y is equal to x squared from 0 to 1. So a is 0, b is 1. Okay. Now, what would be the form for our z of t? That's the question. We still have to identify our k here. Now, our k is obviously taken from your given curve y is equal to x squared. Supposedly, it is y is equal to k x squared, where your k is its numerical coefficient. Since it's y is equal to x squared with 1 here, so our k is equal to 1, meaning our parameterization function of t is actually t plus I times 1 t squared. Okay? This is its form, but not yet to be substituted there, because there might be some cases where the value, the function is not the same. Okay? Now, let's try to solve first its first derivative as needed in our integration. So with respect to t, all the t terms with t will be treated as a variable. So the variable for t is 1 here, plus I will still I in itself. You will have here t squared, so you have 2i t. 2 minus 1, or simply 1. Okay, this is the first derivative. I mentioned earlier, this is already good. I mentioned earlier that we cannot substitute there automatically, but in this case we can, because our given function is originally identified as z. So if I have here f of z of t, is just of course equivalent to z of t itself, as we change the items here, and your z of t is already identified as t plus I t squared. So as mentioned, you can substitute that there, but not all the time the case, because what if this is z cubed? That would mean we're going to cube this and we're going to cube this. So substituting automatically there is not true for all. Only for this example where the given function is z itself. Okay, so z t squared. Now, all of these are identified. Let's proceed now to the integral of f of z dz along the parabolic curve, as its path is equivalent to the integral of f of z of t times z prime of t dt from a to b. Let me change the color as I move it here. The integral, again, our a and b is 0 and 1. You automatically say here is 0 and 1. For your f of z of t is just this one here, t plus I t squared, times your first derivative is actually 1 plus 2 I t dt. Okay. Now, you can of course multiply these two functions, because you cannot move one or this one here, because both of them have t variables. You can multiply them using FOIL method to come up with a 4 terms. Okay, and then they are going to apply all the rest of the properties for integrals. But what I could suggest here is this one here. Another technique we can do here is this. If we let this be equal to u t. So let's use this properly. T plus I t squared. What is du, by the way? The derivative of t is 1. Okay? With respect to t, okay? You have here 2I t. This is with respect to t. As you can see, this is already this form here. Using this as our u. In short, this integral is already identified as u du. The integral of u du. And if we're going to have the integral of u du, where of course our exponent of u is 1, or generally if you have your u to the n du, it's actually identified as u to the n plus 1 over n plus 1. Or in this case, the integral of u du is actually u squared over 2. So aside from multiplying all the terms here by FOIL method, okay, what you can do is, of course, use this process and get this final form, or not final form, the next form. Your u, okay, this is 1 here. The integral of u du is this. So your u is actually t plus I t squared. Okay, you don't have the integral anymore because you already applied the rules of integration here. So you have t plus I t squared. Sorry, the square is here. Square that, that's your u squared over 2 from 0. It's not 1, right? Ah, yeah, 0 to 1. Hey, so this is actually its second form. If we're going to use the FOIL method earlier, you can do that. I could guarantee if we have the same what they call this one, observation with the correct mathematical operations and procedures, we will get the same answer. Speaking of procedures, what we could do next here is this. When we substitute 1 and 0, you will have here the first, you have 1 plus I times 1 squared. By the way, this is only for the numerator, right? Squared of that over 2. Minus, as for 0, 0 plus I times 0 squared. Again, sorry for this. This is just for the numerator. Squared over 2. Okay? Of course, this would be 0. So 0 plus 0 is 0. All of that would become 0. What remains here is this. 1 plus I. Square that over 2. Simplify the square of 1 plus I. It's actually 1 plus I times 1 plus I, which would give us 1. Inner terms I, outer terms I, last terms I squared. And since I squared is equal to 1, you will have here 1 plus 2I minus 1, which gives us 2I. So this is just actually 2I over 2, which is further simplified as I. So for all of these processes, we have here the integral of the given function along the parabolic curve is actually equal to I. All of these processes, including the parameterization, is discussed here in all of these processes. Again, we did this as part of some analysis and integration of previously discussed concepts. Thank you very much for watching.